Hey, what's up guys? Welcome to the first video in our long range series. Today what we're going to start talking about are all the components that come together to make your weapon system. Alright, it's pretty incredible how you can take a sighting system, a firearm, some ammo, and a shooter and be able to repeatedly put a bullet on target exactly where you want to every single time. So what we're going to do today is we're going to talk about a couple of the components of what come together to make this weapon system, and then in subsequent videos we're going to finish off this portion of the series. There are 4 components that we're going to be talking about that make the weapon system that allow you to shoot a target at long distance. Alright, so we have the rifle, we have the optic, we have the ammunition, and we have the shooter. Today we're going to start by talking about the rifle in itself. Alright, so the first thing I'm going to do is I'm going to take this gun apart so we can break it down to all of its components and I can show you everything. Alright, so the first thing we're going to do is we're going to take this rifle apart. I've got a set of fix-it sticks here. If you need a set of these, they're a great tool to be able to work on your own guns. They come with this nice little T-handle and several different bits. It makes taking apart your gun really, really easy and working on it so that you can clean it or whatever you need to do. If you need a set of these, go ahead and let us know. Alright, so now we have our bolt gun completely disassembled. Alright, so now we're going to go down the line and talk about, in order of importance, each part of what makes this gun work. The first thing we're going to talk about is the barrel. Right, the barrel is the heart of any firearm. Right, the quality of the barrel and the characteristics of the barrel are what are going to allow your gun to perform the way you want it to. Alright, if you want a sub-MOA gun, you better have a good barrel. All right, some characteristics of a barrel that you would want for a precision build specifically are, first of all, a heavy contour. When I talk about contour, what I mean is the thickness of the barrel. So if we take a look at my barrel, I have what's called a heavy PAMA contour, where it starts out fairly thick over by the chamber and then slightly tapers off all the way down, but overall it is a very heavy contour barrel. Another good contour barrel is an M24 or M40 contour. Those are the kinds that you'd want, or even a straight taper where there's no contour at all. It just maintains the same exact diameter across the entire length of the barrel. But ultimately, for precision, what you want is something very, very heavy. All right, you also want a stiff metal. And the reason why you'd want a stiff metal is because when you fire a round, the barrel is going to whip and move. It's called barrel harmonics or barrel whip. And the stiffer the barrel, the less whip there is. Okay? So the preferred barrel material or metal material for the barrel for long-range precision is typically going to be stainless steel. Okay, that's because it's a very, very stiff metal, and then also it is very, very heat resistant as well. It dissipates heat very, very well, because as your barrel heats up more and more and more, it's going to whip more and more and more because the metal becomes more malleable. Also, for precision, you're going to want a longer barrel than you typically would on a gun that you might carry around tactically or for a hunt. And the reason for that is because you want to get the maximum muzzle velocity possible out of your barrel or out of your gun. And the reason why having a longer barrel will give you a higher muzzle velocity is because when that explosion takes place within the chamber, the gases will act behind the bullet for a longer period of time, allowing it to continuously speed up throughout the entire length of the barrel. So here I have a 24-inch Bartlein barrel. All right. One other thing to take into consideration that a lot of people ask about is fluting. How does fluting affect your barrel? And if you don't know what fluting is, if you take a look at my barrel, you see that there's this spiral pattern cut into it. All right, so that's spiral fluting. Ultimately, Fluting doesn't do anything to your barrel, okay? So when you look at the fluting, obviously there's metal removed from the barrel to allow it to become fluted, right? Which takes weight off of the barrel and lightens the contour slightly. However, the fluting also increases surface area of the barrel. And the more surface area, the stiffer the stiffer the shape is. So there's a give and take there that pretty much equals out when you take some material off the barrel to flute it, but then if you're worried about it losing its ability, it actually gains the ability back in stiffness to equal out. It also dissipates heat a little bit better, but generally but then because it's got less material, it's going to heat up faster. So the give and take, it ultimately equalizes into, if you want a fluted barrel, you get it because a fluted barrel looks pretty cool. And that's why I got this one. This is what my gunsmith had in stock. He asked me, do you want a fluted barrel? And I said, sure, I'll take a fluted barrel. All right, so there are a lot of questions about barrel break-in, all right, and breaking in your barrel for long-range precision. Generally, the rule of thumb is if you have a caliber less than 30 cal, so 30 cal being 308 or larger, you're going to need to break in your barrel. With 308 or larger, whatever muzzle velocity you're shooting to start is pretty much what you're going to shoot for the entire 10,000 rounds of barrel life that you have. Okay. However, for a 6.5 Creedmoor and smaller, all the way down, you don't need to necessarily break in a 22 caliber barrel, but 6.5 Creedmoor, 6 mil, what you generally want to do is shoot 40 to 100 rounds through the barrel without cleaning it. All right, at that point, what you'll see is an increase in muzzle velocity come out of your gun. After you see that increase in muzzle velocity take place, what you want to do is clean your bore, first with carbon solvent, then with copper solvent to strip any copper from the imperfections within the barrel, and then again with carbon solvent. After that, run a couple of dry patches through, and then your barrel break-in process is essentially done. All right, and then lastly, what we'll talk about when it comes to barrel is barrel life. Okay, so the barrel life again depends on the caliber. Really, there are two factors: the caliber in which you're shooting and the style in which you're shooting. Like I mentioned a little bit earlier, when it comes to 30 caliber, this gun is gonna shoot for 10,000 rounds with no problem. And then all of a sudden, your barrel is just gonna shit the bed. When you get down to those smaller calibers, you're gonna see a decrease in barrel life. And the reason for that is a 6.5 Creedmoor and a 6 mil is essentially built off of a 308 round. And when you take a 308 round and neck it down, you have the same amount of energy coming out of that cartridge but going into a smaller hole, which is going to increase throat erosion within your barrel. We can talk more about that later on when we get into our internal ballistics portion of this long-range series. But as of right now, all you need to know is your barrel life entirely depends on the round you shoot, and then also the style of shooting. So if I'm shooting F-class, fairly slow, precision marksmanship, where I take a shot every minute or so, my barrel isn't going to heat up. And when my barrel heats up, throat is going to erode a lot more simply because there's more heat going through and more energy going through at any given time. Hot gas is moving past the bore. When you're shooting PRS style, where within 90 seconds you may shoot 10 to 12 rounds, you're going to have a shorter barrel life simply because you're shooting that gun so fast over intermittent periods of time to where the gun heats up very, very rapidly and then very, very rapidly cools. All right, moving on from the barrel. Next, the two components that make a barreled action, we've got our barrel and we've got our action. All right, in my opinion, an action is an action is an action. The action houses the bolt, which we have here, and it allows you to chamber around into the barrel and then also provides the firing pin for you to shoot and fire that round. When it comes to an action, really all you need to look for is something that's reliable and well made. Whatever action you have, it doesn't necessarily matter the brand. A lot of them are built off of a Remington 700 footprint anyway and contain a lot of the same kind of characteristics, such as nowadays a 60-degree bolt throw, and then the ability to attach a trigger via trigger hanger. All right, so Ultimately, the type of action you have doesn't necessarily matter as long as you are comfortable with your action, and it's well made and it's going to hold up to the rigors that you put it through, depending on what you're going to use it for. The reason why a bolt gun is so much more inherently accurate than a gas gun is because you have a closed breech system. And with those tight tolerances, it's going to allow less gas to escape, it's going to have less rattle and movement between the parts, and it's going to allow the gun to manipulate in a repeatable way every single time. A skilled gunsmith can easily get the matching of the threads between the barrel and the chamber to be 1/1000th of an inch in tolerance. So, and to put that into perspective, your average human hair is 3/1000ths of an inch. So it's 3 times smaller in tolerance than a human hair is in width. Now, that's pretty much your entire gun, right? This is the part that makes the bullet shoot, right? On here, we also have a couple of different things that ultimately, dependent on the quality of them, will help the shooter in his performance. Of course, to make the gun shoot, you need a trigger. And on here, I have a Timney hit trigger. A very, very nice, crisp trigger is extremely important to precision, and preferably with a light pull. So I have this trigger set to 8 ounces. This thing, you could look at it and it'll go off. I barely have to touch it, which is fantastic because that greatly helps me as a shooter when my reticle is on target to be able to make sure that shot breaks with me inducing as little stress on the actual weapon system as possible. So when it comes to trigger selection, you want something that has probably a variable rate of pull, such as a Timney hit or a Trigger Tech Diamond, and you want to set it to a trigger weight that's comfortable for you, but is light enough to where when my reticle's on target, I don't have to worry about any creep when I'm pulling it back, or have to worry about potentially jerking it and then losing or not having a bad break. So, and we'll talk about what having a bad break of your reticle is later when we talk about the fundamentals of marksmanship. But essentially, you're just looking for a high quality trigger with a light trigger pull. And then flat trigger shoe, curved trigger shoe, doesn't really matter. That's shooter's preference. As we move to the front of our actual muzzle, we have on here a muzzle brake. All right, and a muzzle brake, when it comes to long range precision, is a huge tool. And the reason why is because what this does, it dissipates all of the gas that's coming out of the bore or the muzzle as I'm shooting and sends it out to the side, which not only stabilizes the gun, but eliminates a ton of recoil that's felt. The mitigation of recoil felt is the name of the game for anybody who's a competition shooter, right? It's also a huge deal for potentially even a military shooter, because if I shoot at a person, or if I'm a hunter and I shoot at an animal, I may need to take a second shot. And the worst thing that could ever happen to me if that target is exposed for only a limited period of time is I take a shot, and after that shot breaks, the recoil knocks me off target and I have to find that target again, where I could potentially maintain that target in my sight picture if I just have good recoil management. And something that definitely helps with recoil management is a good muzzle brake. On here I have an Area 419 Hellfire Match 4-port muzzle brake, and this thing will allow a heavy caliber round or a high caliber round like a .308 to still shoot very, very flat with with very little felt recoil. So it's fantastic. All right, so moving away from the barreled action, now we're going to talk about the actual chassis. All right, so if we take a look over here, I'm just going to move this to the side. This is my chassis here. This is an XLR NV chassis. On here I have some weights in the front. Whatever chassis or stock you use, it's really up to what feels good for you, all right? It's personal preference. Is it ergonomic? Do you like the way it feels? Do you like the way it looks? Just like in action, a chassis is a chassis. However, some chassis are made a little bit better than others. So the way an action actually fits into a chassis is it's held in by 2 screws, your rear action screw and your front action screw, and then if you take a look at my actual barreled action here, you can see that there's a recoil lug here. And the recoil lug is what actually makes contact with the action to prevent movement within it, forward, back, left, and right. And that sits right in this compartment over here. So some are made a little bit better than others, to where you may have an action where, as long as it's torqued down properly with the front and rear action screws, you're not going to have any movement forward or backwards within the chassis of the action. All right, however, you may have some lateral deviation, left and right, which you can see here. And it's obviously not going to be very, very apparent when it's all torqued down to spec. However, if you're a PRS shooter and you're on the move and your gun is together and all of a sudden you hit your barrel on the side of a barricade, you may see a lateral shift. What recoil is going to do is it's going to set that action back in place, so you'll only see a little bit of a shift for one round, but it is something to take into consideration. So the more well-made chassis may not have that problem, and the more poorly made chassis may have that problem. It really just depends on what you get. And the way you can test that is just by simply doing a side impact test. That's once your gun is put together, take the gun, hit your barrel alongside something, and see if it held at zero for that shot. All right, so now I'm just going to simply talk about how I put this whole system together. It's really, really simple and easy. You watched me take it apart, but I sped it up. But it was really, really simple and easy to take apart. So again, I'm going to use my fix-it sticks. First things first, I'm going to take my barreled action. I'm going to make sure my bolt is removed from it. It's just a good rule of thumb to not try to torque your barreled action into the chassis while the bolt is in. All right, you could do damage to your bolt that way. I'm simply going to drop my barreled action into my chassis and then lift it up laterally, just holding it in with my hand, and just kind of make sure that I'm getting good contact from front to rear with that recoil lug. Then I'm going to take my front action screw always goes first, and I'm going to torque it in. All right. This is different depending on your chassis, but the general rule of thumb is 45 to 65 inch-pounds. Some people think 65 inch-pounds is excessive. However, in my opinion, torque it down to the maximum allowable torquage, and you'll always be just fine. So, screw that in there. And then torque her down. All right, next is the rear action screw. Let's go ahead and put that in. And same exact thing. All right. And then now I can put my bolt in. As long as my bolt goes in, it closes no problem, I'm good. And I can even do a functions test just to make sure it fires properly. And we're all good, make sure the safety works. No problems there. All right, so now that's assembled. All right, I know you guys saw me take my heat shield off here, or Mirage shield. This is just supposed to stop Mirage from coming off my barrel and getting my way. I don't necessarily need to put it on right this second. Just as is, this gun would function just fine. All right, so just to recap what we covered today, we talked about barrel considerations. We talked a little bit about the action. We talked about a trigger and why having a light trigger helps a precision shooter. And then we talked about the muzzle brake. Coming up in the next video, we're going to be discussing all things about optics. All right, everything about optics and how they work with the gun as a sighting system and what makes them tick. So thanks for tuning in, guys. Stay Apex.